Hello guys and girls, welcome back to another fun-filled, action-packed, non-flipped Algebra 2 classroom with me, Coach Gru. It's been a few days making videos and you know what that means. Start making silly mistakes like forgetting to press the record button. So here we go, round 2. We're doing Unit 4, which is all about solving systems of equations. We're going to be learning a bunch of different ways to solve systems of equations. Notes number 1 is all about solving systems of equations using graphs. Oh boy! So, first with some vocabulary, let's make sure we know it, or at least we've heard it before. So here we go. Linear system is a set of two or more linear equations, y equals mx plus b, that use the same variables. Next, we've got systems of equations. That's what this whole unit's about, so you better know what this means. Systems of equations is a set of two or more equations that use the same variables. And lastly, we've got a solution of a system. This is what we're looking for in all these problems that we're going to be doing this unit. So you got to know what a solution means. A solution of a system is a set of values for the variables that makes all the equations true. On the graph of systems of two equations, the solution is a set of points where the lines intersect. So usually you're going to have multiple equations, right? Those are lines. And the point where they intersect, that is the solution. So for the first topic of the day, we're going to be verifying solutions of linear systems. We're going to use substitution to determine if an ordered pair is actually a solution for the system of equations. So look at A. They gave us the ordered pair. It's right here, 2, 4. All right, and then here's the system that they gave us. Is these two equations, x minus 2y equals negative 6 and 2x plus y equals 8. So how are we going to check if this ordered pair 2, 4 is actually an answer? We're just going to substitute the values into each equation and make sure that they are true when we put the values in. So what's the x value here? It's 2. And what's the y value? Is 4. So I'm going to plug those numbers into the equations where I see x and y and just check if it's true or false. So watch this. The first one, x minus 2y equals negative 6. X is 2 minus 2y. Y is 4, so 2 times 4 equals negative 6. Now 2 minus 2 times 4 is 8 equals negative 6. 2 minus 8 is negative 6. And does negative 6 equal negative 6? Yes, it does. No Galaxy pen. So 1 is true. Now we got to check the other one as well. We got 2x plus, I don't want to write 2x plus y. I want to write 2 times 2 plus y, which is 4. Equals 8. What's 2 times 2, guys? That's 4. Plus 4 equals 8. 4 plus 4 is 8. Does 8 equal 8, guys and girls? Yes, it does. Both of these are true when I plugged in those numbers, which means yes. 2, 4 is a solution to the system of equations. So you guys try B on your own. All right, next up, we're going to be solving linear systems by graphs. So today we're all about, using graphs to find our solutions. So this is it right here. Remember, all these equations are lines, and if we put them into y equals mx plus b, we can graph those lines. But look at both these equations. Neither of these are in y equals mx plus b. Unhappy face, don't like that. We're going to rearrange them into y equals mx plus b. So we got x plus y equals 4. I want y equals mx plus b, so I'm going to subtract x from both sides. Boom. Y equals, I'm going to put the x in front because I want to see mx plus b. So negative x plus 4. That's one of my equations. So I'm going to go ahead and box that so I know where one of my equations is. Next, we've got 2y plus 4 equals x. I need to get the y by itself, so subtract 4, boom. And now I have 2y equals x minus 4. Need to get y by itself. Divide everything by 2, everything. Y equals, x over 2 is the same thing as 1/2 x. And I write that because I like seeing the slope. And then minus 4 over 2, what's 4 divided by 2? That's 2. And so here is my other equation, y equals 1/2 x minus 2. So, to graph these, remember, we got the y-intercept, that's the number in the back. Over here is positive 4, so I'm going to use blue for this first graph. Positive 4 is the y-intercept, so that's my first free point, 1, 2, 3, 4, right here. The slope is the negative. I don't see a number there. That means it's 1, so negative 1. So negative 1, if I want to put in a fraction, is negative 1 over 1. And remember, our slope is rise over run. So we're rising -1. That means going down 1 and then over to the right 1. So I'm going to do that over and over. Down 1, over to the right 1. Down 1, over 1. Down 1, over 1. Down 1, over 1. And then we connect the points. Boom. And then our second line, I'm going to use the maroon. All right, we can see the y-intercept is at -2. So I'm going to start right there. 1, 2, down 2 right there. And my slope is 1 over 2, which means I'm rising 1, going to the right 2. So rise 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. There's my second line. Connect the points. Boom. And we can already see the point of intersection. It is right here. That is my solution. So what is that point? That point is 4, 0. So my answer is 4, 0. Boom. All right, so you guys try B on your own. All right, so if we wanted to do B, here we go. We need to get y equals mx plus b. So 2y plus 6 equals x is not mx plus b. I'm going to subtract 6 from both sides. That gives me 2y equals x minus 6. Then divide everything by 2. That leaves me with y equals 1 over 2. X minus 6 over 2 is 3. So that's one of my equations. Bag that one up. Boom. And then my second equation, I've got, let me get this, okay. 4x equals 3 plus y. All I have to do is get y by itself. So if I just subtract this 3, I'm good. So that leaves me with 4x minus 3 equals y. That's the same thing as y equals 4x minus 3. So there are my two equations, and now let's graph them. The first equation up here, we've got 1/2 x minus 3. The y-intercept is -3. So I'm going to start at -3 and then go up 1 over 2, up 1 over 2, up 1 over 2. Boom. That's my line. Come here, ruler. Boom. And now my second line is going to be in y-intercept at -3. Wow, there's my point of intersection. I can already see it. Let's just finish graphing. Up 4 over 1, because 4 in front of the x is the same thing as 4 over 1. So up 4 over 1, up 4 over 1. That's off the screen. Let's go over here. We can see the point of intersection. It is right here. What is that point, guys and girls? That is 0, -3. So my answer, my solution here is 0, -3. Next up, we're going to learn how to classify these systems. You know, we got these systems of equations, and we can classify them. So there's some vocabulary here. So first up, we've got consistent system. A system's consistent if it has at least one solution. All right. Next up, we got inconsistent system. If a consistent system has at least one solution, an inconsistent system has no solutions. The no solution. Oh man. All right, next up we got the dependent system. That's a system of equations that has an infinite number of solutions. Oh man. And then finally we've got independent system, which is pretty much the same thing as a consistent system. Independent system has at least one unique solution, which means one solution. But mainly we're going to be dealing with these three, so let's just make an effort to remember these three. All right, looking at the back, we've got a visual right here. Heck yeah, we love visuals. Pictures are the best. Okay, first of all, check out these intersecting lines. With intersecting lines, you can see there's a solution right there, right? That's one solution. That's a unique solution. Intersecting lines have one solution. That means it's consistent or independent. All right, next we've got coinciding lines. What the heck is that one purple line? Why is there a purple line on my screen? Because purple equals red plus blue. Blue and red make purple. Which means there's actually two lines just sitting on top of each other. Oh my goodness, right there. So this is actually two lines on top of each other, which means, remember, solutions are the point of intersections. If the lines are right on top of each other, that means there's an infinite amount of solutions, because anywhere is a solution. So with coinciding lines, we have an infinite amount of solutions, which means it's consistent and it's dependent. It's dependent. And then lastly, we've got parallel lines. I hope we know what parallel lines look like. They never touch each other, which means, is there a solution? No, there's no solution. Oh man, which means it's inconsistent. All right. Now with these pictures, we can classify our graph, but look, we can actually classify a system without even graphing, okay? All we have to do is rewrite the equation into our slope-intercept form, y equals mx plus b, and then we just compare the slopes and y-intercepts. Now this star box, this is gold right here, guys, Because check this out. After you get y equals mx plus b form, you check the slopes and the y-intercept. If the same slope is the same and the y-intercept is also the same, well, you pretty much have two of the exact same lines, which means it's coinciding, which means there's an infinite amount of solutions, infinite number of solutions. And that makes it dependent. And then if you have a same slope but different y-intercepts, well, that means you have parallel lines, which means they never touch. There's no solution, which means it's inconsistent. And lastly, if you've got a different slope, two lines with different slopes, they're always going to touch each other somewhere. They're going to run into each other eventually, which means there's going to be exactly one solution, which makes it independent. Independent. So let's put this into practice with these example problems right here. We're going to classify each system and then determine the number of solutions without graphing. Now, we need to put it into y equals mx plus b form though, so we can compare the slopes and the y-intercepts. So first one up here, we got 2x plus y equals 3. I'm going to subtract 2x from both sides. Boom, boom. Y equals negative 2x plus 3. There's one of my equations. Now let's do the other one. I'm going to do it in a different color. So we have 6x equals 9 minus 3y. So I'm going to get, I'm just going to subtract 9 from both sides. And then that gives me 6x minus 9 equals negative 3y. Then I need to divide everything by negative 3 because I'm trying to get the y by itself. Negative 3, negative 3. I'll move this over here. What is 6 over negative 3? That is negative 2. So we got negative 2x. And then negative 9 divided by negative 3 is positive 3, so plus 3, and equals y. So, oh my goodness, we can see that we have the exact same slope. Look at the slopes here. Negative 2 and negative 2. And we got the exact same y-intercept, positive 3 and positive 3, which means these are coinciding lines, which means how many solutions are there? There is an infinite number of solutions. And it is going to be dependent. Boom. All right, so I want you guys to try the second one on the right on your own. All right, so over here on the right side, let's just get our answers now. We got 3x plus y equals 3. We want to get y by itself, so just subtract 3x from both sides. That leaves you with y equals negative 3x plus 3. That's one of my equations. Next equation, we got 2 plus y equals negative 3x. All we have to do here is subtract 2 from both sides. That leaves me with y equals negative 3x minus 2. Okay, we can see that the slopes here, negative 3 and negative 3, those are the same slope. Okay, now the y-intercepts, we got positive 3, negative 2. Same slope, different y-intercept. Those are parallel lines. They never touch. There's no solution, or NS, which means that it's inconsistent. Inconsistent. Boom, there we go. And finally, we're going to have to know how to write the equation of each line and then find the solution to the system. Okay, so this time they gave us the lines, we need to find the solution. That's the easier part. But writing the equations, that's where we might struggle a little bit. So, okay, equation for k. You can see k is the red line right there. There's no slope there. You can see it's straight, right? So there's not going to be a slope. Now, we can see that this crosses the y-axis at 3, which is exactly our equation then. Y equals 3. That is the equation for a horizontal line. It's going to be y equals a number wherever it crosses. So that's my equation for k. Now for L, we can see that's a line and there is a slope. So what we're going to do is we're going to find the y-intercept first. We can see the y-intercept is right here at, let me use a different color. We can see the y-intercepts here at 0, 3. So at 0, 3, I'm going to put plus 3 then, because that is my y-intercepts. Now we're going to pick 2 points. We can see the 2 points right here, and that's going to tell us our slope once we count. So it's down 2 from one of these points, over 3 to the next point. So down 2, which means negative 2, over 3, positive 3, x. And then remember, it's y equals. So y equals negative 2 over 3x plus 3. And the solution, wow, I already wrote it right here. It's the y-intercept. They happen to intersect at 0, 3. So my solution is 0, 3. Boom. All right, let's do the one directly under it together just to make sure we understand how to write these equations. So for k, we can see that the y-intercept is at 1, 2, 3, positive 4. So go ahead, plus 4. And the slope from one of these points to the next is, look at this one. Let's see, it's down 2, 1, 2, over 2, which is the same thing as down 1 over 1, which means it's negative 1. So I don't need to write negative 1x. I can, but I can just put negative x, because when there's no number in front of x, it's understood that it's a 1. And remember, it's y equals. Make sure you write it like this, guys, or you're losing points. You're losing precious points. All right, and equation for L. All right, L, we can see, once again, there's no slope here on L. It's a straight up and down line. What the heck? That's an undefined slope. So we can see it doesn't even cross the y-axis, so it's not going to be y equals. This one crosses the x-axis, though, at 1, 2, 3, 4. So the equation for L is x equals 4. Straight up and down line, the equation is x equals whatever the number is. Okay? So there's our two equations. Now we just got to find the solution, and we can see it's right, where do they cross? Right here at 4, 0. So my solution is 4, 0. Boom! And you guys can try the other two on your own. Anyways, guys, that's going to conclude this first section of notes for Unit 4. See ya in the next one. Peace!